It's awfully tempting halfway through what you've learned in trig to go, why are you torturing us with this? Where is this ever actually used? This gives you a little taste of it. It's not good enough. Trigonometric equations describe sound waves, light waves, X-rays, water waves, electron waves, everything. Are we ready for all that? No. No, we're not ready for all that. So we'll do a point on the ocean going up and down. Yeah, getting ready for all that. But same thinking you need to study all those other things, whether you're in physics or chemistry or whatever. So here's some examples of problem solving. 2 word problems to get you ready, but lots of talk about each word problem, about what I'm doing and why I'm doing it. Okay? A point on the ocean rises and falls as waves pass. In fact, you can picture a little duck sitting out there on the ocean. I know ducks don't go out in the ocean, but just it's a fun example, so let me go with it. So duck sitting out in the ocean, and as the waves go past, the duck's just going up and down as the waves go by. Because the waves go by is the way, by the way. They move by, and the duck just sort of sits there in the same spot. Okay? Suppose that a wave passes every 4 seconds, and the height of the wave from crest to trough is 0.5 meters. I've set up the first question to help you. It says sketch a graph. Do not try to do anything else, but get a graph first. Once you have a graph, you've got a chance, okay? Sketch a graph to model the height of the point relative to its average height. What does that mean? I'm going to explain that in just a second. For a complete cycle starting at the crest of a wave. Do we even know what crest means? Okay, well, we'll get to all that. Here's some details. The reason we do average height when we're out on an ocean is if we did actual height from the bottom of the ocean, the height of the duck would be 1,800 meters or whatever it is, and going up and down 0.5 meters. That doesn't make any sense. So we go, here's, if it was still water, I'm going to put a blue line across there. You don't have to do the blue line. I'm actually just trying to show off and see if I'm actually better at this than I was yesterday. You can decide as you're watching me if I am. Just picture that as, that's what the water would be normally before the waves came by. Still water. Have you ever been? Oh, a friend of mine's cottage up in Goddard. In the morning you get up and the water would be glass, baby, like straight across. Just picture that. That's what we're talking about with average height. So now when we talk about this duck is going every 4 seconds. The height from crest to trough is 0.5 meters. Well, you need a little, just 2 physics words, which are not on the test. I just introduced them here. And if you ask me on the test, what's a crest and what's a trough again, I'll tell you. But let me just show you. Maybe you already can guess. If I build a little wave here, this is the crest of the wave. Have you heard that word before now that I put it in that perspective? Yeah. The waves are cresting as they come in to shore. And then this is the trough of the wave. Maybe unless you live on a farm, you haven't seen trough before, but a trough is the downwards part. And we often feed animals in a trough, a divot, a downwards part. So the height of the wave from the crest to the trough is 0.5 meters. So now the first tough question of the day. How high above the average does the duck get if the distance from crest to trough is 0.5 meters? 0.25. Okay, so that's the difference between amplitude and height of the wave. To the duck's going 0.5 up and down. But we look at him and go, you're not really going, you are going 0.5. It's okay, duck. I understand what you're saying. But really the amplitude, how far the duck's getting from the middle, is 0.25. So I'm just going to put that in there. All that talk just to write down 0.25, because I think that's where the highest is going to be. If you're not quite with me, just wait until I do the next thing, and then you'll see. And then I'm going to write down here negative 0.25, which if you just came in now, you'd be like, what? How can you go negative 0.25? I can, relative to the average. It means the duck's gone lower than he would have been if the water was still. And that's exactly what happens actually when water goes by. You're going up and above and below where you normally would be, because the water didn't disappear. Some of this water from here is just over there. That's what's really going on with waves. You know, there's not more water. It's the same amount of water, generally speaking. All right. So then I'm almost ready, and I'm now showing off because I'm very excited that I think I actually have a handle on some of the things with this active board. I'm out in green pen. The wave passes every 4 seconds. Oh, I wasn't done with blue. 4 seconds. And I have some choices here about my scale. And some of you might have found out that scale is the real challenge here, getting a scale that works well here. I've chosen one that the scale works very well. So I'm just going to go 1, 2, 3, 4. And now, the big moment, where hopefully all that comes together and this makes perfect sense. Oh no, I lost my festive green. There, I got it back. Where does this graph start? It does start at 0. We always start at 0. But what height does it start at? The question will almost always tell you. If it doesn't tell you, it means you can do whatever you want. Yeah? But it'll almost always tell you whether to start at the top, the middle, or the bottom. Starting at the crest, so you need this word here. But again, I only throw that in on the possibility maybe you're taking physics or some sciences later, and I want you to get used to those words. If you were on a test of mine and you want to say, what's crest again? I'll tell you, crest isn't really part of this course, but we use it here. Okay, crest. So this duck starts at a crest right there at the top of a wave. Now, you can draw your waves any way you want. Mr. Todd suggests jump right to the end of the cycle. I think you'll find that easiest as you move forward. You go, okay, that means this duck goes down to the bottom and then all the way back to the up, and that takes 4 seconds for it to happen. So at the 4-second mark, he'll be back at the top. He'll be back at the crest. I think the deepest understanding of sine and cos comes from jumping to the end of the first cycle and going, here's where the end of the cycle is. Now, that means halfway between his 2 crests is his trough, which will be at the 2-second mark, and he'll be at negative 0.25. Are you okay with that? I'm hoping that is a giant click for a lot of people, like, oh, that's handy. I like that. Halfway between is the other side. And then it gets better. Halfway between those two is the middle. 0. And there's the 5 key points. We often call them the key points of sine or cosine, are those 5 points that indicate where the high, the middle, and the low are. If you have those, that's when you call Pizza Hut and order a pizza because you're like, oh, I'm home free now. There's a little bit of thinking to go yet, but I've got the graph. If I got the graph, the rest of it I can figure out. Okay? So I'm going to draw that on there very carefully. See how I'm doing on my drawing today. Oh, it's like I'm a different person today. How much better am I at this today? Learned a few things. Actually, I turned off one of the settings. All that wandering off to the side things, that doesn't happen anymore. I just turned it all off. All right, this is good. Sketch a graph to model the height. Okay, let's do a little better. Science people. Science people should be unhappy with me. Over here, height in meters. And down here, time, seconds. Yes, I know all about the titles, science teachers. Yes, they get very upset about this if you don't title everything, and as they should. But I'm teaching math, not titles. Okay, but anyways, okay. I know it didn't say a duck here, but I think visually, or for visualization purposes, it's nice there. Do you need that title on graphs in my class? No, but I do mention it because you got to go to science class after this, and they'll get very upset if you don't put nice titles on it. Did I do what it said? Sketch a graph, yes. Models the height of the point relative to the average height for a complete cycle starting at the crest of the wave. I should tell you that if waves did go by every 4 seconds, and the height of each wave from crest to trough was 0.5 meters, this would work surprisingly well in predicting where the duck was going to be for 4 seconds, then for 8 seconds, then for 12 seconds. I know waves can change during the day. I'm aware of that. And then weird waves come up. All of a sudden there'll be one that's different. But this works very, very well when we're talking about waves. Sine and cosine, it's like they were built for waves. Every wave that's going on in the universe, it's like sine and cosine are right there waiting to help with these beautiful graphs that describe the situation. Question? Why haven't we used tan yet? Is that what you said? Yeah. It's a great question. 2 reasons. Tan is a much more complicated graph, and tan doesn't have as obvious an applications. As soon as I draw that, everybody goes, water. Maybe you also know that light and sound travel in waves like this. Microwaves, X-rays. Sorry, I don't know where you're at in chemistry class. Are they saying electrons? Are they still telling you electrons are little dots going around a center thing? Are they starting to talk about the wave nature of electrons? Really scary stuff. Yeah? So, as it turns out, virtually everything is a wave function like this. And the tan doesn't fit nicely. Sine and cos, physics people, you'll stop using cos at some point. You just go, let's just use sine all the time, because sine and cos are just transfers of each other. And that's why they're called sinusoids in physics, because it's all sine waves that they use there. Not for any reason, but because they said, let's just all agree. Let's just all use sine, okay? And I'll show you what that mean by that in just a second. Because right now, I don't have to use sine or cos. I could use either one for this graph here. Other questions there? This is how they know what's going to happen with light and sound and electromagnetic waves, and how they know GPS systems. It's all laying right here. We're right on top of it. Lots more to know. Okay. I did what they asked. Good. I sketched the graph. Write an equation. Oh, now this is where you got to start paying attention on what I'm going to do. What I'm going to do is not that difficult. It's not. Sorry. I don't believe it for a second that it's particularly difficult. But there are steps involved to what you have to accomplish here. We'll trade. Yeah? I teach a grade 10 class, and one time somebody was late and gave me one of this, and I ate it immediately. Well, I was trying to get through to them. Like they're after that, they paid attention. I don't know why. Anytime I ever do that with a class, I eat their note. After that, they pay attention. Especially if it's one of those notes where they got to take it back to other classes. And they're like, Mr. Todd ate my note, and nobody believes them. And then when they ask me, I say, no, I didn't eat the note. You know, it's good fun. Write an equation. Okay, write an equation. H at t. And I'll do the first equation in green, because you will be happy with the choice I make. And then we will make another choice, and you will be unhappy. Okay? For now, green, happy. We will be happy with the choice I made. The first choice is, should I use sine, cos, or tan? And tan, we haven't talked about yet. So it's sine or cos. We need someone wise. Wise. Who knows their sine and cos very well, who's like, I know which one you should use. And I'll do the should in green. Yeah. Which one should I use?
Is it cos?
It's cos. Of course it is. Of course it is. Why is it cos? Why is he saying this? Cos is a better choice here. The shape, okay, sine and cos have very similar shape, but so be a little more specific here about the shape. At 0, it's 1. You're like, this is at 0.25. Okay, so we got to do a little better on cos. At 0, it's at the top. It's not wrong to say at 0, it's 1. That's not wrong, but we're going to find out that the amplitudes change. And so at 0, it's at the top. So cos is a better choice here. I'm going to do sine, but it's going to be more difficult, okay? So, cos. Ready? All the transformations. I have good news for my first example, and you'll see I've planned this example out very well. If we're going to use cos, this does not have a vertical translation. It's centered right at 0, just like cos is. It does not have a horizontal translation because it starts at the top. See, I made the first one. Now all we got to think out is the period and the amplitude. Okay, now big moment. If you don't know this, come test time, you got no chance. What's the amplitude of cos usually? 1. If you didn't know the answer to that, that's okay. But come next Thursday, you better know the answer to that. That better be right in your brain. That cos, the amplitude, it normally goes up 1, and then back to the middle, and then down 1. That's why I got you to keep your investigation, so you could look at it and go, what's the amplitude of this one? How far does it get from the center, Ben? 0.25. And some good news. The amplitude just goes here. And maybe you have an aha moment and you're like, oh, that's why you taught method 1 and method 2 yesterday. It's not because you were trying to convince us to do method 2, which maybe I was, but just so you go, what goes up there is just the amplitude. Here, write that in your notes, right there. Right there. Just put the amplitude right there. That's one nice thing. about sine and cosine equations is you can pick off the amplitude right out the front right there. That's sitting right there. Next, the period.
4.
The period here is 4, but what's the period of cosine usually? 360. So this thing's been compressed by factor I don't know. Maybe you do know. So I'm going to write in gold and give you a golden formula. If you memorize nothing for this test but this formula, you'll be happy. So I'm going to write in gold here. Gold. Ooh, do I have other colors? Is there something else that looks more golden than that? No, it's as gold as we get. Here it is. I'm going to write it way over here.
That's orange.
It's gold. I stole the letter K from your physics class.
What's K stand for?
We might have called it B before. The K is whatever number you're going to put right here. K, no. Stop that. The K goes right there. That's that horizontal multiplier, divider. This time I want to find the K value, but look at this. This rearranges so nicely. Here's why you're going to like it. Oops. I'm learning. K is 360 divided by the period. Now, if you don't believe me about how good this formula is, just give it a minute until you see what happens here, okay? So if I want the K, I take the number 360 and I divide it by whatever the period is. What did we decide the period was? 4. And I get K equals 90. Don't give up on this yet. Don't go, oh, it's too hard. It's not. Wait till you see what happens here, because someone else could have got this number without my fancy formula. They might have gone, I can get this without your fancy formula.
So can we just put K equals 360 for P?
It's beautiful. Yeah, I think you're, now I'm just showing off that I can actually change colors again, that I'm not just a complete fool at this anymore. There we go. That gets a nice red heart. That's worth the investment to memorize that formula. If you want that K value, you just go 360 divided by the period. And I've called it K. In previous lessons, we might have called that B or C, but I'm also trying to get through to you that it doesn't matter what letter you call it. It's just a placeholder to go, that's where the K goes. So you see, I put a little K right there, so right there. Now, let's just make sure it works. If you just saw this yesterday, and you saw a 90 there, you'd say, oh, that's a horizontal compression factor 90. If I compress 360 by factor 90, I get 4. Okay? So that's how this all works in the real world. There's going to be some multiplier there in the real world to tell you how much to compress or stretch your function to get the period you want. Okay? By the way, I now have the power to predict exactly where the duck's going to be 3 days from now, 2 weeks from now. I know waves change in the ocean. I get that. But some waves don't change. Light waves, sound waves, those type of things often don't change. And then you can predict exactly what's going to happen at a certain time, a certain place, very easily with one of these equations. If they give you the time, you can plug it in there. You can find the height. Give you the height. You can do the work you did last chapter to solve for the time. But do you have any questions?
I like your shirt.
Thank you.
Like cosine and stuff like that. How do I get that on my calculator?
Sine cos 10.
Yeah, but like the other ones, like.
So secant would be 1 divided by cos.
Okay.
Cosecant's 1 divided by sine, and cotang's 1 divided by tan.
So
that's they're all the reciprocals.
Okay.
All right. Any questions there? Okay, as promised, to just ruin your day, I'm going to do it with sine. Especially for you physics people. You physics people will just do sine all the time. Here we go. A lot of it's the same. Please don't over worry about this. If you get to the test and it asks for the other one and you don't like it, there's good news. The amplitude's still the same.
What is this one for? This is for sine. Oh, I see.
The k value, which I'm going to continue to use the word k from now on, because that's where that's going. That number will always be called k from now on.
Well, what's that number represent?
The horizontal compression. So this, because it was time 4 for a period, it's been compressed by factor 90. This formula helps you walk through it, though. So you don't have to think. You just like, bang, get the answer. The only thing that will change here to be sine is it will have moved right or left to be a sine graph.
Right one.
He says right 1. I think he's wrong, but he's doing the right thinking. My brain tells me he's wrong. So let's just, he just needs a couple of words. Here's what he knows about sine. I'm going to get his words, and I need someone to add something to his words. Where does sine start?
0.
It starts in the middle. Do you see what I did there? I changed it a little bit to get ready for the next example. It starts in the middle, comma. Sine starts in the middle. There was something after that.
It goes 90.
Yeah? Let me draw. There's sine right there. It starts in the middle on the way up. There's two middles. One's going up, one's going down. Sine starts in the middle on the way up. So I encourage you to highlight. This is easy if you just do this. You just go highlight in orange. Okay, yeah. And you go, where's middle on the way up?
Right there.
There.
I thought that's gold.
It is.
So why'd you say orange?
That's funny. A good way to fail the next test, really, when you think about it. Yeah. Do you see now? You see I said he was right, but just needed some extra words? He went middle, which was beautiful, but middle on the way up. So this sine graph got moved right 3. Woo. A little bit difficult. That's a little bit tricky. So let me just put that in there. It's been moved right 3, so I need pen, red, right,
So it's -3.
-3. Before they complain about my...
Orange.
Pen? No, still not pen.
That's the highlighter.
I know, but
It's
it's
not working.
still wanting to be...
You gotta click the pen on the right.
You
so
gotta-
where the highlighter is. Yeah, to the right of that.
That.
Oh, now they're both highlighter.
Now you click the pen.
It doesn't want me.
Click on the highlighter.
You gotta hit the
Still clicking
green.
highlighter, man.
Hit the one with the green. The one with the green. Like the pen with the green on top.
Where the highlighter
No,
is.
no, you're not seeing. I got to switch the pen. That is the pen controller. That's the touch controller. So I need
Hit the
this.
touch controller because it's just sitting on the highlighter.
There it goes. Yeah, it's argumentative. All right, what do we decide? -3? For right 3. Okay? But there was another choice there. And this could mess you up in the homework, because if they decide to do it a different way, it might mess you up when you're checking your answer. I could have gone the other way.
And do 270 degrees.
Where else is a middle on the way up? It's not on my graph. I've got to picture it.
6. Negative.
Left 1. I could have chose left 1 too. I'm not trying to mess you up. I always go this way. I always go, where is it right? I always go right with these. But someone could go left 1 and get the same answers. It will give the same answers. So they could have gone left 1. Okay? But I think you like the first one better. Don't let me sidetrack you, but I just mentioned that. Okay. Any questions about that? Mr. Todd, are you going to let us choose? Like, are you going to force us to do one where I have to do sine when I really want to do cos? The answer is no, but maybe the question will force you to. Maybe you won't have a choice. Okay? So I think the next one forces us into a situation. Right? I think. I believe I remember that right. So we got one more to go. And if you've fallen asleep, you better come back for just a second because I'm going to say something important here. This says the water depth in a harbor is 21 meters high at high tide and 11 meters at low tide. We live inland. Do you guys know what tides are? Happens a little bit at lakes, but it happens big time at oceans. Basically what's happening, I can't resist getting sidetracked a little bit. Here's basically what's happening. Let's see how I do here. Shapes. We want an earth here. What color is the earth? Essentially it's blue. But I don't want it to be blue today. I want it to be
Yellow.
green.
Gold.
Earth, got it? Yes? And then I need a gray over here.
That's white.
Here. The moon. Come on. Give me some more colors, baby. Oh, yes. The moon. And Phil. Hi, Phil. No. Come on. Come on. Oh, yeah. Wasn't I complaining last week about more colors? Now I got them. Oh, I don't know. Moon coming up. Moon. Good? Here's what happens. The moon has gravity. Not as much gravity as us, but it's got some gravity. And so it has enough gravity to affect the water on the planet, and I'm going to exaggerate it big time. This is too much. We would all be dead if this was to scale. But just to help you visualize it, I'm going to go now pen blue. Here's what happens with the water in the earth. Oh, that's not blue.
That's red.
Blue. Here's the water on the earth. Yeah? Water on the earth. Good? But the moon pulls a whole bunch of the water towards it. And so near the moon, there's more water. I've really exaggerated. I want you to go home and think that there's a giant water wave traveling around the earth. There is a water wave traveling around the earth, but it's not that big. It's a few meters tall. But if you live by the ocean, this matters. That is, if you go out and you bring in your boat that you've been out on the ocean with, and you park it in the sand, right up against shore, and it's ready to go back out, and you go in for lunch, by the time you get back, it's 12 meters into shore, and the water's way out there now. Yeah? It goes in and out as the day goes on. Very scary stuff if you live near the ocean. Anyhow, back to what we have to do. It says the water depth in a harbor is 21 meters high at high tide and 11 meters at low tide. I don't think that's realistic, actually. I'm just using some numbers that we can work with. One cycle is completed approximately every 12 hours. Find an equation for water depth as a function of time. It says find an equation, and look, I gave you a graph. If I do this in the test, I'll do the same thing. I'll be like, build a graph. Trust Mr. Todd. It didn't ask for the graph. Make the graph. So you've got a chance at this. So here we go, building this graph. Up here, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. That's the depth in meters. And this is time in hours. Good? And how many hours? One cycle, 12 hours. Well, I'm going to do every second. Does that fit? I'm only doing that to help you be able to see what's happening, okay? And so water depth. After low tide. So we got to start at low tide. What's the depth at low tide? 11. And my really big piece of advice. If you're understanding what's happening here, I only have a couple of really big pieces of advice here. And the first one is jump to the end of the cycle. Do 11 and then jump and get the last point, which is 12 hours later, it'll have done a full cycle. And so at 12 hours, we're back at the 11 meter mark. That will really help you in these word problems. Jump to the end of the cycle, because then what is the depth at 6 hours, halfway between those?
The top of it.
The top, which is the high tide, which is 21. Now brace yourself. This is the most important part. I don't think it's hard, as long as you're thinking properly. Where will it be at 3 hours?
Halfway.
Halfway between, okay? And some people will give you an equation for that. They'll say, and I'll write it down in a second, they'll just say, add those together and divide by 2. Totally works. I like it. It's not what I do, to be honest. I just think about it and go, okay, what's halfway between 20 and 11? And it's, what is it, 16? 11, 12, 13, 14, no, sorry, 11, 12, 13, 14, 15, 16. Right there, and that's at 3 hours.
That would also be at 9 hours.
5 up, 5 down. And then so that at 9 hours, it's at that spot as well. But don't let me away with it, folks. Don't just go, yep, I get it.
Is that just, that's it? Just 5 spots?
He asks a perfect question. That's it? As long as you got those 5 spots? I've added a couple words to what he said, and the answer is yes. That's what's so beautiful about sine and cosine. Those 5 dots are enough for me to now draw my nice smooth curve. And this will be shockingly accurate. Like if you went to the ocean, and this was the data, now you could predict exactly what the tide's going to be. You could decide, oh, if we're going out fishing, don't come home until 6 o'clock when the high tide's in. Stay out till, and they plan their fishing days around what the tides are going to be. Or they build a dock that floats. Yeah, there's options here. I'm just saying. This will be shockingly good at predicting it. Now, friends, my number 1 piece of advice here. As soon as you draw any of these curves, do yourself a giant favor, and I'll do it in gold. Draw the center line on. That's my best piece of advice today. And label it. That's at 16. Unbelievably helpful. May not seem like it right now, but it's unbelievably helpful in everything we have to do next. Oh, activate the menu first, then use your finger. Okay, I get it. It said find the equation. It didn't say make the graph, but I'm telling you, make the graph. Make the graph. Then you can answer the question. So here we go. D at t equals. Now, what would you like to use? Sine or cos? See, last one there was an obvious choice. What do you like? He likes sine. You like cos? We're going to do both. Yeah? And we'll talk about why you might like one over the other, because neither one's a perfect option here. But we'll go up here, we'll go with sine. And then I'll do it again down here with cos. And I'm going to do them both at the same time so you get to know how to do it both ways, and how they're different and how they're the same. Ben, what are you going to say? Are you going to tell us the number?
No, I'm going to tell you that your graph is off.
Uh-oh. What? Where?
12 times is like 1 over, bottom right.
There we go. Yeah.
Oh, right there. It was supposed to only be 2 squares, and I went right to the end. Thank you. Oh, I'm glad about that. I didn't want that on a video. Which, didn't I press the eraser? My hand's the eraser. That's all gone now. Let's fix this up. Did you catch it and do it right on yours?
Yep.
Or did you just follow along with me and do it wrong?
I didn't even do the same scale.
It's not that big of a scale.
I did small.
Pencil eraser.
I did one of them.
This is going well, actually. You may not be impressed, but I'm pretty impressed by how good I'm doing here with this new board. It's good. Is it?
That's right.
Good job, Mr. Todd. Good job counting to 12. Okay, so first thing, What's the amplitude? I'm going to show you 1, 2, 3 ways maybe to get the amplitude. So I want you to think there's one way to get the amplitude. Can anyone just look at this situation? Now that I've got the center line on, and they know what the amplitude is. They can just look at it. I'll give you a hint. It's not 21.
It's 5.
It's 5. How did you get it?
Because that's the middle.
Yeah, with this middle on here, the amplitude's right there. Half the height. With that middle line on there, you don't need any fancy formulas. You don't need anything crazy. You can just see that it's a 5. Okay? Some people make a formula for this. I'll put it on the next page. You can copy it down if you like formulas. They make a formula, which I do not love, but you can have it if you want. Amplitude equals max minus min divided by 2. 21 minus 11 is 10, which is the height of the wave, and then divided by 2. I'm acting like I don't like it. I like it fine. I find, though, that students have trouble memorizing all the different formulas. So if you draw the center line on, you can just count. The third way is to take the max and subtract the middle line, which you might think is the same thing, but it actually is just a little bit different approach to it. All right, now next, the period. The period's 12, so without the formula, what factor did it get compressed by if it came from 360 to 12? 30. Sometimes you can do it in your head, but sometimes it gets too hard to do in your head because the numbers don't match up right, and that's where this formula is good. I'll write it again in orange, more because I'm just working very hard on making sure I can transition between colors. K, take 360 and divide it by the period, which you can use P for period. Physics people will use, you guys got to it yet? T for period? Yeah, T, okay. And I'll just go across here. 360 divided by the 12. 30. That's what I'm going to call now the K value. 30. But that's not quite right just yet. I've got to still deal with the phase shift, it's called. But now there's an up-down. Important question. What is sine normally centered at? What's its horizontal line normally? 0. That's an important detail. Now the center line is 16. You see, I wrote it right on there. I like writing that center line on there because that's this number out here. It's been moved up 16. You can pick that right off with the center line. Last piece of the puzzle. Does it need to be phase shifted? And the answer is yes. Sine starts in the middle on the way up. Where's the middle on the way up in this one? 3. So if you know what you're looking for, that's not all that bad right there. Highlighter, yellow, finger. Oh, worked, good. Getting better. So it's been moved right 3. That is difficult. I won't act like that is easy. T minus 3. Whew. That's hard. A lot of work there. To do it with cos, I have some great news. Same amplitude. If this is going to be a cos, still 5 is the amplitude. Same K value. Same vertical translation. All of that's the same. All it could change is the phase shift, the horizontal translation. So 2 choices here. I'm going to put another one. So if you're thinking and you can't decide what to do, there are actually 2 choices of how to do this. Where does cos normally start?
1.
Yeah.
The top.
The top. Where's the top here? No?
6.
That's at 6. So I could go right 6. That could work. I challenge you to say I can make one without a phase shift. I can do something different with cos. Cos normally starts at the top. This one starts at the bottom.
So it's reflected.
Reflected. You could also choose that move. Both would be correct. So someone at the start could have said, let's use cos because we can just reflect it. That's a perfectly good answer too.
What?
I'll take that.
Oh, you talking about a book, like my binding?
No.
Oh my
Has
gosh.
buttons and numbers. Oh yes.
Didn't forget it.
Incidentally, do you need one of these?
What?
Do you need one of these?
No, it's okay.
Let me rephrase. You need one of these. Do you have one of these?
Yeah, I just keep forgetting to bring it.
Oh.
So did I.
Do you have any questions about these very tough questions? Yes, it is my job to walk up here and make them seem like, oh yeah, no problem. Yeah. Got to really focus here. John, question.
Why don't you just do the opposite? Or like, you know, like the phase shift for some right 3.
Yeah.
So like, why not just go left 3 instead?
You're almost there. You're almost onto something we'll do in advanced functions. Instead of going right 3, it would be left 9. Or sorry, left 6. You could just go the opposite way, the other part of the period. Yes. Absolutely, yeah. Because the period's 12. You go right 3 or you can go left 9. Either one of those works because of the repetitive nature. We'll get into more of that in advanced functions. We'll go, there's a lot of repetitiveness here. Can't we come up with some formulas to relate all the repetitiveness here? And the answer is yes. Questions there? Okay, so if you look on the website, I want to show you both days' homework. Today, I taught all the word problem versions of it. Now, I left one tough question in yesterday's homework on purpose. So if you did the homework, you're like, how am I supposed to do this? And then after watching today's lesson, you're like, okay, I get that now. Then most of the tough ones are here in this list today. Now, if you didn't get to yesterday's homework yet, and you want to know which order to do these in, then go back to yesterday's homework. And I made a list there of what questions you could do in the 7.3 and 7.4 based on how I taught it. I break it up a little different than the homework list does. Okay? If you haven't done any of the homework now, though, you've seen both lessons. Let's say you were here yesterday, and you're here today, but you just haven't done any homework. Well, you can do everything now. I taught you everything, so you should be able to handle all situations.